Hi everybody. Today we're going to be converting grams to moles and moles to grams. We're going to start with the grams to moles conversion. So, our first problem is to convert 32.5 grams of copper to moles of copper. So, let's set up our little equation like this, and we're starting with 32.5 grams of copper. Now, what we want to do is get rid of units of grams of copper. Right from the periodic table, it's 63.54 grams of copper is equivalent to 1 mole. And when we go through and do that, we find out that it is 0.511 moles. Now, let's think about the process we used to get here. First, we have a gram mass of something. Okay, fair enough. Next, we find the atomic or molecular mass from the periodic table, and I was able to do that there. That's what the 63.54 came from. Then we set up the calculation, we rounded for significant figures, and at the end we ask ourselves the question, does it make sense? That is, does it make sense that I'm getting a number here that is less than 1? Well, if 1 mole of copper weighs 63.54 grams, then 32.5 grams of copper should be less than 1 mole. It is. It's a little more than half. So yes, this number does make sense. Now let's do the reverse. Let's convert from moles to grams. And here we're being asked to convert 0.500 moles of calcium chloride to grams of calcium chloride. So let's set this up again. And we're going to start with what we're given, a half a mole of calcium chloride. 1 mole of calcium chloride has a mass of 110.98 grams, and that comes from the periodic table. If we do this, 55.5 grams of calcium chloride is what we have. So let's look at the process again. We start with the number of moles of something. We find out the atomic or molecular mass from the periodic table. We set up the calculation, and then we round for significant figures. And then again, we ask ourselves the question, does it make sense? I have half a mole of calcium chloride, and 1 mole of calcium chloride will weigh 110 grams. So it does make sense that a little more than half the mass of calcium chloride is in half a mole of calcium chloride. So yes, this number does make sense to me on a conceptual level. Now, we're going to go from grams to atoms. It's a little more computationally expensive for us, but I think we can get there. So, how many atoms are in 32.5 grams of copper? So we're going to start with that gram unit right there. We're going to set this up, and you notice we have more space here for more things to go into our calculation. So first we're going to get rid of units of grams and convert it to units of moles using a number from the periodic table. And then we're going to remember that every 1 mole of copper contains 6.022 times 10 to the 23rd copper atoms. That's Avogadro's number. We put that into our calculator, we do it right, and that comes out to 3.08 times 10 to the 23rd copper atoms. Again, here we start with a gram mass, we convert it to moles, we convert that to atoms using Avogadro's number, and then we round to significant figures, and we ask ourselves the question, does it make sense? I have less than 1 mole of copper by about a factor of, 1/2, so I should have less than Avogadro's number of atoms, by a factor of almost 1/2. So yes, this number does make sense. It also makes sense that it's a large number of atoms, 10 to the 23rd, where I'm starting with a small number of grams. Let's do the reverse. Now we're going to convert from atoms to grams. So here we have what's the mass of 7.50 times 10 to the 23rd atoms of barium. So let's set this up. Again, we've got more space. We're going to start with our barium atoms, cool, and we're going to get rid of units of atoms and convert it to moles. So 1 mole contains Avogadro's number of atoms, and then 1 mole of barium from the periodic table weighs 137.33 grams. We put that into our calculator, and we get 171 grams of barium. So we start with the number of atoms, we convert to moles using Avogadro's number, we convert to grams, we round for significant figures and ask ourselves, does this make sense? 1 mole of barium would weigh 137 grams. I've got more than 1 mole of barium, so I should have a mass that is more than 137 grams, and I do. It's 171, so this makes sense. So let's take it all in. We have a process here, and that usually starts with looking at what we're starting with, looking at where we're going to in terms of grams, moles, atoms, etc., and thinking ahead. Will this be a big number or a small number? It's a good idea to have that in mind. And then asking yourself the question, does it make sense when you're all done? That is, does this number really fit with the reality? So I'm going to give you a challenge question. This is something you should try. How many molecules are in 1.50 kilograms of sodium nitrate? So this is a different kind of question because I'm not giving you grams, I'm giving you kilograms. I think you know how to deal with that. I'm also asking you about molecules. So a hint I'm going to give you is that 1 mole of sodium nitrate has Avogadro's number of molecules in it. If you do this correctly, you should come up with an answer of 1.06 times 10 to the 25th molecules.